Bismillahirrahmanirrahim. We are now on chapter 8, or according to your textbook, this is chapter 35, entitled as Image Formations. Alright, in this chapter, we are going to apply the law of reflections and refraction from chapter 34 in order to investigate the image, that results when light rays encounter flat or curved surfaces between two media. We are going to continue to use the ray approximation and assume light travels in straight lines. Firstly, we are going to study the geometry of image formed by mirror and lenses, and then determine technique for locating an image and predicting its size. Alright, so we are going to combine the information given before, and we are going to form a few steps of calculation to determine the position of the image, in order to get a type of the image needed. Right, so let's begin with the most basic, which is image formed by flat mirrors. So if you see here, we have a mirror, right? Flat mirror. Let's say this is point O, here is the object, alright? So the position of the object to the surface of the mirror, where we have reflection happen, based on law of reflections. Remember, incident angle must equals to the reflected angle. So this is the object, this is the distance of the object to the reflecting surface, which is our mirror, and here is our image, which is at the back of the mirror, and the position of the image to the reflecting surface of our mirror is Q. Alright, as we know, the ray going to be reflected and enter our eyes, right? So from here, we are going to see the image of the object. So since the ray is not going to be focused, right, or intersect at any position on this side, actually the ray or the light is actually can be sort of focused at this point, where it's going to form image at the back of the mirror. A real image is formed when all light rays passes through and diverge from the image point. A virtual image is formed when most, if not all, of the light rays do not pass through the image point but only appear to diverge from that point, as shown here. The image formed by the mirror in this figure is virtual image, because the ray seems like appear to be coming from the image or combined at the image point. So we can conclude that for flat mirror, the image produced by flat mirror always virtual image. Another idea about real image can be displayed on a screen. For example, as we can see on the projector screen or movie theater, right? But virtual image cannot be displayed on screen, right? So for this figure, this is actually for point object and also point image of it. Alright, so let's take a look on another picture for this one. Again, still about flat mirrors, image formed by flat mirror, but now we have extended object, where we consider the shape of the object and also the height of the object. Alright, so this is our flat mirror. Alright, so if you recall back the ray diagram technique, you have to consider at least two, but the best is actually 3 rays, okay, but 2 rays are enough, right? The first one is the from the top of the object, okay, projected onto the mirror and then reflected back. Okay, this is the first ray. The second ray, okay, from the top of the object, okay, projected onto the center of the mirror and then reflected back. For this one, the angle of the incident must be equal to the angle of the reflected ray. Okay, so by combining extrapolation line from the first line, okay, and also the second line where it meets here, this is the top of your image. So again, recall that the image produced by a flat mirror will be virtual image, right, which is at the back of the flat mirror, right? So lateral magnification is symbolized as M, is equivalent to image height, okay, H prime, over the object height, H. Because the triangles PQR and P prime QR are congruent, okay, therefore magnitude of the P and magnitude of the Q is the same. That is how we get the height of the object and the height of the image is the same. So it means that the M going to be equivalent to 1. It means that what? The size of the image is exactly the same to the size of the object. For flat mirror, if we have M equivalent to positive 1, what does that mean? Okay, the H and H prime is the same, one thing, and positive value signify that the image is upright, okay, as this. Okay, it means that image is upright. What does that mean by upright? It means that, okay, the head of the arrow here, okay, still pointing upward, similar to the object. Okay, so this is the meaning of the upright. If it is inverted, means that the head of the arrow will be downward, opposite to the object. So for this case, it's upright, we call it. Okay. A flat mirror produces an image that has an apparent left-right reversal. Okay. So, what does that mean by left-right reversal? Okay. Take a look on this diagram. So in this diagram, the image in the mirror of a person's hand, okay, is reversed. Okay, this is the right hand, this is the left hand. Okay, so this is the mirror, right? Here is the image of the right hand. It seems like or similar to the left hand of the person. The image in the mirror of a person's right hand is reversed, okay, front to back, which makes the right hand appear to be similar to the left hand. This reversal is not actually a left-right reversal. That's why we have apparent. The reversal is actually a front-back reversal, caused by the light rays going forward toward the mirror and then reflecting back from it. Okay, now let's move to concave mirrors, right? Concave mirrors mean it's a spherical mirror where we have the shape of a section of a sphere. Okay, if let's say we have a whole sphere, a section of a sphere, this is the shape of our mirror, right? That is why we call it concave. You see cave here, right? So this is the mirror, this is the reflecting surface here. This is the other part here is the support. And we have a center of the curvature. We have radius, okay, of imaginary sphere. Alright, we have principal axis, and point V here is the center of the mirror. So if we consider, okay, a point object, okay, from C, which is here object, alright, so what will happen? Firstly, okay, there are few rays that going to be projected onto the mirror from the object and being reflected. So the combination point, okay, for the ray will be the position of the image. Okay, similar application or law to the flat mirror just now. It's just that the effect of the curvature here will be slightly different. So let's examine this figure where we have a concave mirror, and then object is placed here having h height. Okay, so the first ray will be passing through the center of the curvature, and then projected onto the mirror, and then reflected back, passing through the center again. So the first line. The second line is paraxial ray. Paraxial ray going to move from the top of the object, projected onto the center of the mirror, and then being reflected. The incident angle must equivalent to the reflected angle according or obeying the law of the reflections. Okay, the point where these two ray intersect will be the top of our image. So if we see here, the image is inverted, upside down. Alright, we're having h prime as the height. Right, so from here there are certain things that we can observe, where alpha here is the same to this alpha, okay, and we know that this theta is the same to this theta. So from this we can have tangent theta is equivalent to h over p, and tangent theta also, okay, for the yellow triangle here, is h prime over q. So we have tangent theta is equivalent to h over p, and this is for orange diagram or triangle here. For yellow diagram or triangle here, we have tangent theta also is equivalent to negative h prime over q. So equate these two equations, we are going to have right. And if we want to have m is equivalent to h prime over h, we're going to have negative q over p, which is equivalent to lateral magnification. And further analysis in terms of geometry of this triangle, tangent alpha here, the green triangle here, is equivalent to h prime, negative of h prime, okay, over r, the radius of the curvature, minus q. And tangent alpha also equivalent to h over p minus r for this alpha, this triangle. Alright, so again, this equation is equal to this. Rearrange h prime over h, which is, this is actually equivalent to m is equivalent to negative r minus q over p minus r. Alright, so we can do rearrangement of this equation where it can be simplified into 1 over p plus 1 over q is equivalent to 2 over r. where r is the radius of the curvature. Okay, so by taking object at infinity position, okay, so if this is infinity, 1 over infinity plus 1 over q is equivalent to 2 over r. 1 over infinity give you 0. So you are left with 1 over q is equivalent to 2 over r. So now q is equivalent to r over 2. And r over 2 is actually focal length of the mirror. Okay, focal length of the mirror, this one. And this point we call it focus point of the mirror. Okay, so how to get this? Okay, you have to use object at very far distance. Okay, that is the meaning of the infinity position. This is the schematic diagram, and here is the physical diagram. So now our equation here can be rephrased in terms of 1 over p plus 1 over q is equivalent to 1 over f. This is what we call mirror equation. This one, mirror equation. Okay. Okay, so now, right, from this equation, and finally it brings us to this, right? If we notice here, okay, the focal length of a mirror depending only on the curvature, because it's depending on the r. So it's only depending on the curvature of the mirror, not on the material of the mirror. Okay, whether it's made from glass or it made from plastic, let's say. Okay, it doesn't matter, right? The one does matter for f is actually the radius of the curvature, not the material of the mirror itself, right? For convex spherical mirror, okay, the image formed by the object will be virtual, okay, because it's at the back, and then upright, okay, and behind the mirror. Okay, so the convex spherical mirror also sometimes called as diverging mirror, because the ray from any point on an object diverge after reflection as though they are coming from some point behind the mirror. Seems like it's coming from behind the mirror. Okay, the image is virtual because the reflected rays only appear, okay, to originate at the image point as indicated, okay, by the dashed line here. Furthermore, the image is always upright and smaller than the object. This type of mirror is often used in the stores to foil shoplifters, okay, because we can see wide angle, more image can be observed, right? That is why we use it also at the junction. We do not derive the formula for convex mirror because the mirror equation just now is also can be used for convex mirror. Okay, convex mirror and sign convention. If we're talking about mirror, okay, the law that involved is actually reflections. So we consider this side as front or real side, okay, and this side going to be back or virtual side. Okay, if the P, the position of the object, and Q will be positive, it is within this side, the front. Okay, if the position of the object or image is at the back of the mirror, okay, it's going to have negative. Negative mean virtual, okay, by right, because the law is reflections. Okay, there is no light exists at the back here, right? All the lights incident you point a mirror going to be reflected back, right? So we can conclude this information into table 35.1, where we have object location. Object is in front of mirror, rear object is positive. Okay, if the image also in front of the mirror, positive, and we call it rear image. Height, okay, height of the image. If it is positive, it means that upright. If it is negative, it means that it's inverted. Okay, for focal length of and radius r, okay, positive when mirror is concave. Okay, this is important. It's going to be negative, it means that the mirror is convex. And lateral magnification m, if it is positive, it means that the image is upright. If this one is negative, it means that the image is inverted. Example 35.3. The image formed by a concave mirror. A spherical mirror has a focal length of positive 10 cm. A. Locate and describe the image for an object distance of 25 cm. We are going to use mirror equation where we have 1 over P plus 1 over Q is equivalent to 1 over F. Alright, so now we want to have the Q, okay, the position of the location of the image. Right, so 1 over Q equivalent to 1 over F minus 1 over P. So from here, your Q is 16.7 centimeter and it's positive. To describe more about the image, you need to figure out its lateral magnification. Okay, so from here you will get negative 0.667. So if you see in terms of magnitude, for the M here, it's less than 1. Okay, so what does that mean? The image is smaller. Okay, the image is smaller in comparison to the object. And the negative here, it means that the image is inverted, right? And because the Q here is positive, right? The image is located on the front side, okay, of the mirror and is real. Okay, so if you want to check, you may use ray diagram like this. But for your syllabus, no need for you to be able to sketch the ray diagram. This is just to check. Okay, so the image is inverted because you've got negative sign, and the magnitude of the M is less than 1. It means that reduced in size or smaller compared to the object. And for the Q information, it's positive. It means real image in front of the mirror. Part B. Locate and describe the image for an object distance of 5 cm. So now we have P equivalent to 5 cm. Right? So substitute into this equation, you will get your Q negative 10 cm. From here, we know that the image going to be virtual, okay, because it's negative. And then to check the size of the image, we're going to calculate the M, negative Q over P. So substitute everything. The negative here, you have to bring it during calculation of this. You will get positive 2. In terms of magnitude, it's more than 1. It means that the image is larger, double, compared to the size of the object. And positive of the M going to give us information about the image is upright. Okay, you may check by using ray diagram like this. Suppose you set up the bottle and mirror apparatus illustrated in the figure shown and described here in part A. While adjusting the apparatus, you accidentally bumped the bottle and it begins to slide towards the mirror at the speed of Vp. How fast does the image of the bottle move? Okay, position of the image by this equation that we already derived before. Okay, and we know that speed is equivalent to dq over dt. So what is our q? Here is our q. D of the q over dt. So differentiate this function, okay, to the respect of time. You will get this, and then finally to this, and substitute the value of the information of P and Q there. You will get your VQ is equivalent to negative 0.44 Vp. Okay, so what does that mean? The speed of the image is less than the speed of the object. Okay, that is the meaning of this final answer. Example 35.4, the image formed by a convex mirror and automobile side view mirror on the passenger side, as shown in the photo, shows an image of a truck, okay, at the back there, right, located 50 meters from the mirror. The focal length of the mirror is negative 0.6 meter. Find the position of the image of the truck. Right. So as we know, side view mirror on automobile is actually convex mirror. Okay. So the object is in front and the image will be at the back of the mirror. From here, the equation for the position of the image will be, okay, according to this, substitute the value of the given information, you will get your position of the image is negative 0.59 meter. So what does that mean by negative? Okay, it's virtual image. It means that at the back of the mirror. B, find the magnification of the image. So lateral magnification is equivalent to negative Q over P. So substitute negative 0.59 over 50, you will have positive 0.012. What does that mean by positive? It's upright. It's less than 1, it means it reduced in size.